Imagine absolute nothingness. No space, no time, no matter. There were no colors, no sounds, not even the concept of before or after. Only the void, a silence deeper than anything we can conceive. And then, in an instant so brief it defies our understanding, something happened. A point. Not a point in space, but space itself condensed. An infinitely small point, unimaginably dense, incomprehensibly hot. A singularity. And there, in that moment beyond time, everything burst forth. Space, time, energy, the laws that govern everything we know and even what we don't yet understand. The universe was born. Not in a single corner, but everywhere at once. From that primordial instant, a spectacle began. A cosmic dance of particles and forces, chaos and order, darkness and light. And over billions of years, stars ignited, galaxies formed, planets emerged. Until, on a small blue dot lost in the vastness, consciousness awakened and began to ask questions. What you're about to witness is the most extraordinary of all stories. The story of how everything from the most distant stars to your very own body came to be from a single moment of creation. This is our origin. And the most astonishing part is, it's still being written. Explosion in empty space. It was space itself being born and expanding. Imagine that, in less than a second, the universe grew from something smaller than an atom to a size larger than an entire galaxy. This initial phase, known as cosmic inflation, was a rapid and dramatic expansion that laid the foundation for everything that would follow. Space expanded, the fundamental forces of nature began to separate, as if taking their places in a carefully choreographed cosmic dance. Gravity, which keeps planets in orbit. Electromagnetism, responsible for light and the forces we feel in daily life. And the strong and weak nuclear forces, which govern interactions within atoms. At that moment, the universe was a boiling, chaotic soup. With fundamental particles, even more basic than atoms, quarks and gluons, endlessly colliding in temperatures and energies unimaginable to us today. It was the universe in its purest, most primitive form. A place where the rules we know today were still forming before everything condensed and organized to give rise to stars, planets, and eventually, life. This moment is the root of everything. The foundation of the cosmos around us, and the origin of every atom that makes up your body. To understand this early phase is to understand the essence of our own beginning. After about 380,000 years of continuous expansion, the universe finally cooled enough for a miracle to happen. Throughout all this time, the cosmos had been a turbulent sea of intense energy and wildly moving particles, like an uncontrollable fire where nothing could remain stable. Electrons and protons wandered freely, charged with energy, unable to come together into more complex structures. But when the temperature dropped to a critical level, something extraordinary occurred. Electrons began to slow down and combine with protons, forming the first simple atoms, mainly hydrogen and helium, the basic building blocks of matter. This process, called recombination, was a fundamental transformation in the history of the universe. Until then, the universe had been opaque and dense, a true fog through which light couldn't travel freely. But with the formation of atoms, the fog lifted, making the universe transparent for the first time. Suddenly, light could travel unimpeded through the newly formed space. This primordial light, known as the cosmic microwave background, is a relic of the Big Bang, an echo we can still detect with special instruments, billions of years after that moment. It's like an ancient photograph of the universe, capturing a time when it was just 0.003% of its current age. If you look closely at the map captured by the Planck satellite, you'll see a delicate mosaic of tiny dots and color variations. Each of these tiny fluctuations represents a primordial seed, regions where matter began to concentrate. These slight concentrations of matter, almost imperceptible at first glance, were the starting point for the formation of everything we know. As time passed, these seeds grew, attracting more matter and forming giant clouds that would become the first galaxies. Within those galaxies, stars began to form, casting light and heat, creating the conditions for planetary systems to emerge. And finally, billions of years later, those stars and planets gave rise to the conditions necessary for life to emerge, even here on our small blue planet. This was the moment when the primordial darkness began to lift. When the universe lit its first true light, the light that marked the beginning of everything we can now see and feel. That light is not just a memory of the past, it's the foundation of all existence, the beacon that guides us in our quest to understand the cosmos. After the diffused glow of the cosmic microwave background faded, the universe entered its most enigmatic period. An era so dark that astronomers call it the cosmic dark ages. For over 100 million years, the cosmos was a theater of shadows. There were no sources of light, no twinkling stars, no swirling galaxies, only vast oceans of neutral hydrogen, so cold that their temperature hovered just 50 degrees above absolute zero, floating through the intergalactic void. But in this seeming stillness, a silent force was shaping the destiny of the universe. Gravity, though invisible to the eye, dark matter, a mysterious substance making up 85% of all cosmic matter, began weaving an intricate cosmic web. Its gravitational filaments acted like enormous spider webs, slowly pulling hydrogen atoms into their grasp. These gas clouds, initially sparse, gradually condensed over countless ages. As they clumped together, the pressure at their cores rose exponentially. The atoms, once distant, began to collide with increasing frequency, and the temperature climbed, 1,000 degrees, 10,000, until reaching the millions required to ignite stellar alchemy. Somewhere, at some moment in this primordial universe, one of these clouds crossed a critical threshold. At the instant when the first hydrogen nuclei fused into helium, releasing pure energy through nuclear fusion, the cosmos witnessed its first dawn. That initial spark, brighter than tens of millions of suns, was the cosmic alarm that ended the universe's long night. The first stars, known as population 3 stars, were bluish titans living short but violent lives. Their spectacular deaths, in supernova explosions of unimaginable proportions, would seed the cosmos with the heavy elements that would one day form planets. In life, the dark ages were over, and with their end began the true story of light in the universe. And then, after 200 million years of cosmic darkness, the impossible happened. In the cores of primordial gas, where gravity crushed atoms with brutal force, temperatures reached 10 million degrees. The critical point where the magic of nuclear fusion begins. At that exact moment, the first stars in the universe ignited their thermonuclear furnaces. These were not stars like the ones we see today. Known as population 3, they were bluish colossi, 100 times more massive than our sun and millions of times brighter. Their interiors functioned like colossal cosmic alchemists, transforming hydrogen and helium into elements never before seen: carbon, oxygen, nitrogen, the fundamental building blocks of life. But such brilliance came at a cost. Living fast and dying young, these primordial stars burned through their fuel in just a few million years, a blink of an eye on the cosmic timescale. Their deaths were as violent as their lives. When they exhausted their cores, they collapsed under their own weight, exploding in supernova of unimaginable energy, scattering the freshly forged elements across the cosmos. Post-dramatic twos. Every atom of iron in your blood, every particle of calcium in your bones, every molecule of oxygen you breathe. It was all created in those first stellar furnaces. We are, quite literally, stardust, the legacy of those extinct giants. But for those elements to come together as planets, oceans, and eventually life, the universe needed something even more violent, something capable of turning chaos into order. The early universe was about to take its next evolutionary leap. With the emergence of the first stars came the first seeds of cosmic order. Tiny dwarf galaxies, each containing between 10,000 and 10 million stars, began to gather in a gravitational dance that would shape the cosmos forever. These pioneering structures were drawn together by an invisible but ever-present force, dark matter. Forming vast cosmic webs stretching across the universe, these dark matter filaments acted like skeletons upon which distant stars could assemble. Over billions of years, these embryonic galaxies began to collide and merge in events of unparalleled violence and beauty. When galaxies met, their stars rarely collided. The space between them was simply too vast. But their interstellar gases did crash violently, creating shock waves that triggered bursts of star formation. Our own Milky Way is the result of such ancient mergers. To this day, it continues to cannibalize smaller galaxies, like the Sagittarius dwarf galaxy, which is being literally torn apart by our own. Its material is being absorbed into our galactic disk. Each of these mergers left behind identifiable scars, stellar streams, halos of ancient stars, and distortions in our spiral arms. They are the bruises of a violent past that, paradoxically, made stable galaxies like ours possible. And so, from collision to collision, from fusion to fusion, the universe wove its tapestry of light, transforming primordial chaos into the majestic structures we now admire in the night sky. These cosmic clouds are the cradles of stars, gigantic wombs of gas and dust where gravity performs its silent, constant magic, shaping the destiny of the universe. In their dense cores, clumps of matter begin to slowly collapse, drawn together by invisible forces, merging under increasing pressure and heat. When the pressure reaches 15 million degrees, something extraordinary and fascinating occurs. The miracle of stellar ignition, the moment the eternal fire of stars is lit. Inside every star, a true nuclear inferno pulses relentlessly, generating energy and light. Hydrogen atoms are crushed with unimaginable force, their protons fusing into helium atoms through reactions that release colossal amounts of energy. That energy is the light that bathes the cosmos, illuminating the dark vastness of space. This same fusion creates increasingly heavy elements, carbon, oxygen, nitrogen, essential for life as we know it, the true building blocks of our being. But every star carries within itself the seed of its own destruction. As it consumes its precious fuel, it marches inevitably toward its final fate, a fate determined by a single decisive variable, its mass. Modest stars like our own sun follow a gentler and more peaceful path. After billions of years burning through their fuel, they expel their outer layers in one final cosmic breath. This act creates planetary nebulae of ethereal, almost magical beauty, true works of universal art. Meanwhile, their cores collapse into white dwarfs, glowing embers that shine quietly, and it will take trillions of years to fully fade away. But giant stars, those true cosmic titans, face a very different, dramatic fate. When a massive star exhausts its fuel, its iron core can no longer support the immense weight pressing down on it, and it collapses in mere milliseconds. What follows is an explosion of unimaginable proportions, a supernova, the most violent event the universe has seen since the Big Bang itself. For weeks, this explosion can outshine an entire galaxy, overwhelming everything around it. The shock wave from this blast races through interstellar space at incredible speeds, around 30,000 kilometers per second, scattering the heavy elements forged in the heart of the star across the cosmos. Gold to adorn our rings, uranium to power our plants, calcium to strengthen our bones, all of it born in these final cataclysmic moments. And so, in the death of these titanic stars, the possibility of life is born. An eternal cycle of destruction and creation that echoes through space and across infinite time. A cosmic dance that shapes the universe and everything within it. In the absolute and profound silence of the cosmic vacuum, the true masters of the galaxies lay hidden. Mysterious and powerful entities, gravitational monsters so dense and compact that not even light, that tireless traveler, could escape their invisible grip. Supermassive black holes, some weighing billions of suns, waited patiently at the pulsating heart of almost every galaxy. Silent, relentless sentinels, shaping with their invisible power the fate of the cosmos over infinite eras. When a star or a gas cloud ventured too close to these dark abysses, extreme gravity revealed its most cruel, unforgiving, and inescapable face. Matter began to stretch to unimaginable limits, into filaments thinner than atoms, in a brutal process known as spaghettification. The particles making up that matter accelerated to 90% the speed of light, heating to millions of degrees, emitting cosmic screams in the form of X-rays, screams that, though inaudible, could be detected by distant telescopes millions of light years away. But these monsters weren't merely agents of absolute destruction. They were also the great architects and sculptors of the cosmos. Their power shaped entire galaxies, influencing the evolution of stellar systems, regulating the distribution of matter across the vast universe, and in a near paradoxical twist, governing the endless cycles of stellar birth and death. Part of the test falling into their abyss was expelled in colossal plasma jets, so powerful and energetic they pierced through entire galaxies, stretching across hundreds of thousands of light years. These violent yet essential jets acted as true cosmic sculptors, carving gigantic cavities into dense molecular clouds, sweeping through space, regulating the birth of new stars, and preserving a delicate and complex balance between destruction and creation. This is M87, a cosmic giant and the first black hole humanity ever photographed directly, an image that forever changed our understanding of the universe. Its shadow, a region of absolute darkness from which nothing, absolutely nothing can escape, would engulf our entire solar system, swallowing planets, moons, even the sun itself if they were within its reach. Its plasma jet stretches over 5,000 light years, launching energy and particles across unimaginable distances, a radiant beacon piercing the cosmic dark, announcing its presence in the void. This cosmic beacon has shone with unwavering intensity for more than 13 billion years, illuminating the edges of the universe since its earliest days, when all was still chaos and formation. Paradoxically, without these devourers of worlds, without these silent, invisible monsters, galaxies, and perhaps even life itself might never have emerged. They are the true invisible architects of the universe, weaving order from primordial chaos, shaping structures and phenomena on scales so vast and complex they defy human comprehension. They are silent and powerful entities that command the destiny of stars, galaxies, and everything we know and love in the cosmos, maintaining a delicate, invisible, and essential balance for the existence of all that exists. Violent, explosive, and spectacular, scattered their treasures across the vast cosmos. Each minuscule grain of interstellar dust, floating silently through deep space, carried within it the essential elements for the construction of life. Carbon atoms, the fundamental building blocks of organic chemistry, that over countless eras would assemble into long and complex molecular chains. Oxygen, abundant and eager to bond with hydrogen, creating water, the fundamental, indispensable liquid for nearly every known form of life. And iron, the heavy metal destined to form planetary cores, supporting internal structures and enabling the existence of magnetic fields that protect atmospheres and make life possible. In the cold, dense molecular clouds, regions where temperatures hovered near absolute zero, the chemistry of the universe took its first quiet, delicate steps toward complexity. Simple organic molecules like methanol and formaldehyde, as well as amino acids, the fundamental building blocks of proteins, began to form on the icy surfaces of these dust grains. It was a slow process, almost imperceptible on human timescales, but it marked a true chemical revolution. The universe, until then in a grand spectacle of light, energy, and matter, was becoming a cosmic laboratory, experimenting with the basic components that would eventually give rise to life. When these fragile yet fundamental chemical bricks reached planets still forming, the true miracle of existence began to unfold. Comets and asteroids, cosmic messengers loaded with ice, dust, and complex organic compounds, bombarded these young, hot, and chaotic worlds, delivering their precious cargo of water and essential molecules for life's chemistry. On some of these worlds, oceans would slowly become salty, atmospheres would begin to stabilize, creating the ideal conditions for increasingly complex biological processes to emerge. And in at least one of these special cases, environmental conditions would be just right for inanimate matter to make the most extraordinary leap of all, to become life. Self-replicating RNA molecules would emerge, triggering an endless chain of increasing complexity, a journey that, over billions of years, would lead to the first simple living organisms. This marked the starting point of the incredible diversity of life forms that would one day populate planets, and ultimately give rise to consciousness and intelligence. And so, in a quiet, modest, and seemingly insignificant corner of a common galaxy, orbiting a yellow middle-aged star of unremarkable appearance, a vast and silent universe finally awoke to itself. A slow, profound, and irreversible awakening toward ever higher levels of consciousness, complexity, and life. An unfolding journey that would continue for ages to come, shaping the future of everything we know and everything we have yet to discover. In a universe of blazing stars and cataclysmic supernovas, of black holes devouring entire worlds and galaxies colliding in spectacles of cosmic violence, a silent miracle happened, not in the bright center of the Milky Way, not among the densest star clusters, nor in the hottest or most active regions of the cosmos, but in a forgotten corner of a secondary spiral arm where a modest yellow G-class star shone. There, orbiting that unremarkable star, a cosmic speck of dust. A rocky planet, wrapped in primitive magnesias and bathed in filtered sunlight, achieved the impossible. It maintained liquid water on its surface for billions of years. It was not a momentary accident. It was an almost impossible balance to repeat. The exact distance from the star, neither too close nor too far. The presence of an atmosphere dense enough to retain heat and protect from radiation. And the gravitational dance with a giant moon, which stabilized the planet's axis and softened the seasons. In the depths of primordial oceans, where black smokers spewed minerals at scorching temperatures, organic molecules found refuge. There, between superheated water and the icy currents of the abyssal depths, in microscopic pores of volcanic rocks, life began to take its first step. Primitive nucleic acids formed in cycles of wetness and dryness. Lipids spontaneously created small bubbles, protocells. Simple molecules like hydrogen cyanide, poisonous today, acted as catalysts in this ancient alchemy. And then, between 3.8 and 4.1 billion years ago, it happened. A molecule, maybe RNA, maybe PNA, maybe something that never appeared again, organized the atoms around it and made a copy of itself. An imperfect copy. And in the imperfections, in the random variations of this primitive replication, lay the secret of all life's diversity. What followed was a long, chaotic, and beautifully resilient dance. A planetary symphony of attempts, failures, and persistence. Cyanobacteria appeared, and with them, photosynthesis. Producing oxygen, a toxic gas for life at that time, and completely transforming Earth's atmosphere. New organisms adapted to this new world and used that oxygen to evolve even further. One cell engulfed another, and instead of destroying it, they formed an alliance. That's how eukaryotes emerged, complex cells that would form everything from plants to animals. With every mass extinction, life not only survived, it reinvented itself, evolved, adapted, and over time became increasingly complex. Until one day a creature looked up at the sky and asked, "Where do we come from?" Everything we are, every breath, every memory, every thought, started here, on this pale blue dot suspended in a sunbeam. On an improbable planet lost in the vastness of space, where chemistry turned into biology, and biology, against all odds, became consciousness. For 4 billion years, Earth pulsed with life, but in absolute silence. No words were spoken, no questions were asked. Trilobites sailed the shallow Cambrian seas, ancestral mollusks buried themselves in shifting sediments. Dinosaurs stomped firmly across continents still forming. Tropical forests exploded in forms, colors, and patterns of almost indecipherable complexity. But none of these creatures knew in any sense that they were alive. All followed an invisible, relentless, and blind script, that of natural selection. And then, in a tiny lapse of geological history, something changed. In the warm, moist brains of small nocturnal mammals that survived the asteroid catastrophe, neurons began to form new connections. And these connections were not just for survival. They began to represent things, to carry symbols, to create internal maps of the outside world. Not just where to find food, not just how to escape predators, but how to simulate possibilities. Imagine dangers before they happened. Imagine futures that did not yet exist. Imagine what another creature might be thinking. At some point between electric synapses and emotional pulses, something absolutely new emerged: consciousness. Perhaps it happened on a night like this in an African savanna forgotten by time. While the fire crackled and cast dancing shadows over the dry grass, a primitive hominid, not very different from us, raised their eyes to the sky. And there, among the stars, they saw not only light, they saw something more: a pattern, a puzzle, an invitation. At that moment, something extraordinary happened. For the first time in 13.8 billion years of silent expansion, the universe saw itself, not through telescopes or equations, but through moist eyes and a curious mind. Millions of years later, that curiosity would evolve into science, into myths, into art, into language. Decades ago, Frank Drake tried to translate our cosmic restlessness into a formula, an equation estimating how many technological civilizations might exist in our galaxy. Even assuming the most optimistic parameters, the results were humble: 20, maybe 30. But these estimates ignore the true miracle. The miracle is not in the numbers, it is in the fact that any number exists at all, that any mind on any planet has reached the point of asking a question. Because every time a baby reaches out a finger to the moon, something cosmic happens. Every time a scientist adjusts a spectrograph trying to capture signals from another world, something ancestral awakens. Every time a poet writes about infinity or an artificial intelligence recreates the birth of stars in digital art, the universe is folding over itself, looking inward, thinking. And maybe that is its true purpose: not to expand forever, not to generate matter or energy, but to generate understanding, to generate meaning. Because when a part of the cosmos becomes capable of looking at the whole and asking, what is this? Why do I exist? Then perhaps, finally, the universe has awakened. When Galileo Galilei pointed that rudimentary tube with lenses at the sky and observed, for the first time, small points of light orbiting Jupiter, he was not just doing science, he was, unknowingly, taking part in the cosmic event of profound meaning. Because at that moment, it was not just a man looking at distant moons, it was the universe itself, through a conscious fragment of itself, discovering that it did not revolve around itself. The impact was devastating. For centuries, we had believed ourselves to be the center of everything. But there, with that tube pointed into infinity, one of humanity's most comforting illusions was shattered. For the first time, we understood that there were other centers, other orbits, other worlds. That discovery was just the beginning. When Newton scribbled his laws in ink on parchment, when he described that the same force that made the apple fall governed the movements of celestial bodies, it was as if the universe was writing its own grammar. When Hubble, centuries later, pointed a spectrograph at distant galaxies and saw that they were all moving away from us, he realized that the cosmos was not static. It breathed, it expanded, it evolved. Each equation, each theory, each graph traced on parchment, paper, or pixel is the universe decoding itself. Every photon that reaches our telescopes, coming from stars extinct for billions of years, is a message from the past being read by its own future. And when Neil Armstrong stepped on the moon, that was not just a leap for humanity, it was something much more poetic and much older. It was stellar matter, refined over eons, reorganized into consciousness, returning to literally touch its place of origin. Today, we spread our eyes throughout the solar system. Orbiters on Mars, probes on Jupiter, robots studying Saturn's rings. We send messages recorded on golden discs, containing sounds of Earth and maps of our location, trusting that one day they may be read by intelligences that might not even share atoms with our biology. We are building machines that not only obey orders but learn. Algorithms searching for patterns in radio noise, hoping to find traces of civilizations that might have flourished and disappeared billions of years ago. We are, in a way, living bridges, connecting an unconscious past to futures we can barely imagine. Because we are more than observers. We are the translators of the cosmos. We transform the silent violence of the Big Bang into symphonies and theories. We convert the blind dance of subatomic particles into poetry, art, language. And when one day, whether in a few decades or in a time so distant that our languages will have vanished, another consciousness finds our interstellar probes, listens to our music, and deciphers our images, it will be the universe finally finding its own reflection. Most doesn't stop. It never has. Even now, at this very moment, as you listen to these words, our galaxy, the Milky Way, is speeding at more than 400,000 kilometers per hour toward Andromeda. Invisible to our eyes, yet inevitable, this colossal dance will culminate in a collision 4 billion years from now. Two islands of stars entwining, warping, merging in a spectacle of gravity and light. And if Earth still exists in that distant time, the night sky we know today will vanish. In its place will arise a cosmic watercolor, painted with 1,000 suns crossing the horizon. But our story doesn't have to end with the last breath of the sun, because the same laws that shape galaxies, that bend time and drag light, also open doors. Doors to the future, doors to other worlds. Every gram of matter in our bodies carries with it a journey of 13.8 billion years, from the furnace of the Big Bang to the tips of our fingers. And that legacy was not forged just to disappear. Perhaps centuries or millennia from now, when the first interstellar ships cross the great abyss between the stars, what they carry will not be just technology or engineering. They will carry the essence of what we have become, They will carry our dreams, our doubts, our questions. They will carry with them the poets of quantum, the weavers of possible realities, the children of supernovae who have finally learned to give life back to the cosmos. Perhaps our destiny is not just to survive, but to multiply meaning in the void, to bring the spark where there was only silence, to create futures where consciousness is not an exception, but an inevitability. Silence. Then, this is not a goodbye, it's a see you soon, because the universe, that silent author of galaxies, black holes, and dreaming beings, still has much to write. And for the first time in all its infinite history, it has gained conscious pens